Alright students, welcome to the Microsoft Academy. So we are going to be looking today at the diffusion law questions. So we have two questions on diffusion law, which is also the Grant's law of diffusion. So we have that calculates the ratio of the diffusion rates of helium and methane. So we are given the molecular mass of helium as 4, then carbon is 12, and hydrogen is what? Is 1. So now we said in our previous class that the Grant's law of diffusion gives us the relationship between the rates of diffusion and the molecular mass of that gas. So which it says that the rate of diffusion is inversely proportional to the square root of the molecular mass. So if we should rearrange this and get different states, which is the initial and the final state, we are going to see that the formula will be square roots. So we are having m2 all over m1. So this is the first initial rate of diffusion, the final rate of diffusion. This is the molecular mass of the first gas. Then that is the molecular mass of the second gas. So now from the question here, we are asked to find the ratio of diffusion between helium and methane. So the question is strictly on the ratio. So when you talk about ratio, it means you are dividing. So we talk about the ratio. So this is the ratio of helium, which means helium comes first, then methane, and methane is CH4. So with that, we can be able to calculate this, then we have solved the problem. So now our R1 behaves like the helium, and our R2 is that of the methane. So now what we need in this question is to know the molecular mass. And so if we try to write this using the symbols, we'll be having the rate of diffusion of helium all over the rate of diffusion of methane. Then we have the square root of the molecular mass of methane all over the molecular mass of helium. So this is how we solve it. So remember, this is what we are looking for. That's the ratio. So we need to know these values. So how do we solve it? We need to write the formula back. Methane is CH4. So to get the molecular mass of methane, we are going to be having C plus 4 of hydrogen. So we have carbon here is 12. So we have 4 times hydrogen. So hydrogen is 1. So if I should punch this will be 4 plus 12, which will give us 16. Then we also get the molecular mass of helium. Helium is already given in the question as 4. So it's just an atom there, so you just have 4 as the molecular mass. Now, solving this means that the ratio between helium and methane will now be square roots. We have the molecular mass of methane, which is 16, all over the molecular mass of helium, which is 4. So 4 can go here. 4 here is is 4. So what we'll be having is square root of 4. So square root of 4 will give us 2. So which means that 2 is in the correct answer. But in the option, you might not see 2. What you'll be seeing is 2 is to 1. Now how is this so? Because when you say 2, 2 is all over 1, right? So that means 2 goes for that of the helium, and 1 goes for that of methane. So that means the correct answer is 2 is to 1, not 1 is to 2. So 2 is to 1 is the correct answer. So now let's solve another question. We have question 2. It says that under similar condition, the time required for this, so this is the volume there. So I'll call this one V1 is 300 centimeter cube. Then of is sulfur dioxide, which is given as, so the sulfur dioxide is SO2, so that's the formula for it, and we say that it escaped through a small hole at a time, so the time is given as 1 hour 20 minutes. Then we're also given the volume in this of methane, so I'll use V2, and they say there is given as 150 centimeter cube, and we also have the time as 20 minutes. So what is the molecular weight of what? Methane. So we want to find the molecular weight of what? Methane. So we go back to our diffusion law, which is given as R1 all over R2, which is square root M2 over what? M1. So if we are dealing with the sulfur dioxide, we have XO2, and here will be for methane. Then remember 2 here is for methane, and this is SO2. So now from the question, we are not given the different masses, the molecular mass for sulfur and this, but we know that sulfur is 32 grams per mole, and oxygen is what? 16 grams per mole. So these are constant values we should remember. So if we should come to the question, what we are looking for is the molecular mass of what? Methane. So this question is a little bit technical. So what we are going to see is that we are not giving the rate of diffusion of SO2, we are not giving the rate of diffusion of CH4. So, but we know that the rate of diffusion is given as the volume all over the world, the time. So where we have the different volumes, so V1 and T1 is given. So that means if I want to get for the rate of diffusion of SO2, we are going to be, since the first case there is on SO2, that is 1, so the volume there is 300, and the time is 1 hour 20 minutes. So this will give us 300 divided by the time. But this other time here, T2, is given as 20 minutes. So we have to convert T1 to be 20 in minutes. So here, what we have is 1 hour 20 minutes. So 1 hour 20 minutes is what? If we convert it generally to minutes, what we simply do is need to know that 1 hour is 60 minutes. So 60 plus 20 will give us 80 minutes. So that means the time here is 80 minutes, which you can point in your calculator. You can cancel out this, then do the rest mathematics. So you can see that from here we have 3.7 centimeter per minute. Then let us get the rate of diffusion of methane. Now for methane, we are looking at the second case, so which the volume is given and the time is given. So we have 150 centimeter cube as the volume, so 150 divided by the time. The time is already in minutes, so which is 20 minutes. So if you substitute, you can see that 0 will cancel out here. Here we'll be giving you 7.5 centimeter per minute. So this is how we get the rate of what? Diffusion. Now we have the rate of the diffusion, so we can be able to look at the molecular mass of SO2. We have it as X plus 2 of oxygen. So this will give us 32 plus 2 of oxygen is 16. So when you multiply this, it will be giving us 64 grams per mole. So now we go to substitute. Our rate of diffusion of SO2 is given as 3.7 from our calculation, and then the rate of diffusion of methane is 7.5, is equal to square root. Then the molecular mass of methane, which we are looking for, divided by the molecular mass of SO2, which is what 64. Now we can punch this in the calculator, but what you see is the square root here. We want to remove it and bring it over to this place. So if the square root lives here, so what it means is the square root is no longer on this side. It crosses this side. It becomes all what squared. Now we can make M2 M's the subject formula. So we have MCH4 is now, so this will cross multiply with this. Then you can point this in your calculator, square it, then multiply with what? 64. So if you do that, we'll be having 64, then 3.75 all over 7.5 all squared. So in the calculation we got 16 grams per mole. So that is how you get the what? The molecular mass of what? Methane. So we are also going to look at other laws, the ideal gas law, the Van der Waals law, and how to solve with them in the next video. So if you are just joining us, subscribe to the channel and you'll be seeing more videos on physics, chemistry and maths in this channel. Thank you.